Okay, so welcome to array slicing, accessing subarrays. Just as we can use square brackets to access individual array elements, we can also use them to access subarrays with the slice notation marked by the colon character. So the Numpy slicing syntax follows that of the standard Python list. To access a slice of an array X, use this. X start stop step. If any of these are unspecified, they default to the values of start is equals to 0, stop is equals to size of dimension, step is equals to 1. We'll take a look at accessing subarrays in one dimension and in multiple dimensions. So now we will look at the one-dimensional subarrays here. Look at one-dimensional subarrays. Now, starting it off with x is equals to np dot range, which gives array 1 2 3 4 5 6 7 8 9. Now we'll write x colon 5. That gives the answer 0 1 2 3 4 till 4. So now we'll write x 5 array 5 6 7 8 9. Now x array 4 5 6. 0 2 4 6 8, which is every other element including 0. Now we'll write x 2 every other element starting at index 1, array 1 3 5 7 9. So a potentially confusing case is when the step value is negative. In this case, the defaults for start and stop are swapped. This becomes a convenient way to reverse an array. X equals to, sorry, that gives then 9 8 7 6 5 4 3 2 1 0. All elements are reversed. So to reverse from every other from index 5, we will use x 5 minus 2 5 3 1. Now we will talk about multi-dimensional subarrays. We'll talk about this. So multi-dimensional slices work in the same way with multiple slices separated by commas. For example, let's look at the example. x2. This is the example. Now let's write x2 square bracket 2 12 5 2 7 6 8. Now we'll write so that all rows every other column x2 2. Finally, subarray dimensions can even be reversed together like this. x2 colon double colon minus 1. That gives answer 7 7 6 1 8 8 6 7, and it goes on. So now accessing array rows and columns. Now we will do this. One commonly needed routine is accessing single rows or columns of an array. You can do this by combining indexing and slicing using an empty slice marked by a single colon. Now we will do print the bracket x2 square root. We'll write first column of x2, that results in 12, 7, and 1. Now, first row of x2, now we'll write row. Twelve, 5, 2, 4. In the case of row access, the empty slice can be omitted for a more compact syntax. Sorry. We have to use square brackets. Twelve, 5, 2, 4. Now we will tell you about subarrays as no copy views. Subarrays as no copy views. So one important and extremely useful thing to know about array slices is that they return views rather than copies of the array data. This is one area in which Numpy array slicing differs from Python list slicing. In lists, slices will be copies. So consider our two-dimensional array from before. Print. This is this one. Let's extract a 2 by 2 subarray from this. x2 sub print x2 sub. This gives answer 12, 5, and 7, 6. So now if we modify this subarray, we will see that the original array is changed. Let's observe that. x2 sub 99 print x2 sub. Now it's 99, 5, and 7, 6. So now print 99, 5 to 4, 7, 6, 8, 8, 1, 6, and 7, 7. This default behavior is actually quite useful. It means that when we work with large datasets, we can access and process pieces of these datasets without the need to copy the underlying data buffer. So now we will use creating copies of arrays. We'll study this. Despite the nice features of array views, it is sometimes useful to instead explicitly copy the data within an array or a subarray. This can be most easily done with the copy in this parenthesis method. Now let's do this. Sub. $99, 5, and 7, 6. Now if we now modify this subarray, the original array is not touched. Now let's write x2 sub copy x2 42, 5, 7, and 6. And now let's print This gives the answer 99,524,7688,1677.